branch circuit conductors for motors receive their required protection from a motor overload protective device. This device is specifically sized to protect the motor itself from damage resulting from overloads. Overloads are abnormal operating conditions that can cause the motor to draw excessive current. The motor overload protective device is typically implemented as a thermal overload relay or a circuit breaker. Critically, these circuit breakers are equipped with a trip curve that's carefully designed to protect the motor from damage when overload conditions arise. To understand this better, let's delve into the specific requirements outlined in the National Electrical Code, specifically Article 430, which deals with motors, motor circuits, and controllers. This article provides the guidelines for selecting the appropriate overload protection for motors. It is important to differentiate between overloads and short circuits or ground faults. An overload is an overcurrent condition that persists for a longer duration, typically caused by the motor being subjected to excessive mechanical load. A short circuit or ground fault, on the other hand, is a much more severe overcurrent condition that occurs almost instantaneously. The protection against short circuits and ground faults is provided by a separate device, such as a circuit breaker or fuses, sized according to the requirements of Article 430, Part 5. A motor overload protective device is designed to protect the motor and its branch circuit conductors from the damaging effects of prolonged overloads. The selection of the motor overload protective device is based on the motor's full load current rating, nameplate information, and the type of motor. The National Electrical Code provides tables and guidelines for determining the maximum allowable size of the overload protection. For example, Section 430.32a on and Code provides guidance on overload protection for motors rated more than 1 horsepower. For motors with a service factor of 1.15 or greater, or a temperature rise of 40 degrees Celsius or less, the overload protection shall be sized no more than 125% of the motor's full load current rating. For other motors, the overload protection shall be sized no more than 115% of the motor's full load current rating. It is crucial to understand that these percentages are based on the motor's full load current as indicated on its nameplate, not the ampacity of the branch circuit conductors. The branch circuit conductors, in turn, are sized to carry the motor's full load current, as determined by Section 430.22. This section generally requires that the branch circuit conductors have an ampacity of not less than 125% of the motor's full load current. This ensures that the conductors can handle the normal operating current of the motor, as well as any temporary increases in current due to starting or momentary overloads. Now, consider the relationship between the overload protection and the short circuit/ground fault protection. The short circuit/ground fault protection device, as per Section 430.52, is intended to protect the branch circuit conductors and the motor itself from high-level faults. The maximum allowable size of the short circuit/ground fault protection device is typically much larger than the motor's full load current, often several times the full load current. This is because the short circuit/ground fault protection device must be able to quickly interrupt very high fault currents without nuisance tripping during motor starting or normal operation. The motor overload protective device is set to trip at a much lower current level, closer to the motor's full load current, to protect the motor from overheating due to prolonged overloads. This coordination between the two types of protection is essential for ensuring both motor and conductor protection. The overload protection safeguards against relatively low-level, long-duration overcurrents, while the short circuit/ground fault protection safeguards against high-level, short-duration overcurrents. To illustrate with an example, suppose a motor has a full load current of 10 amps. According to Section 430.22, the branch circuit conductors must have an ampacity of at least 12.5 amps, 125% of 10 amps. If the motor has a service factor of 1.15, the overload protection could be sized to a maximum of 12.5 amps, 125% of 10 amps, as per Section 430.32. The short circuit/ground fault protection device, such as a circuit breaker, could be sized much higher, possibly at 25 amps or even higher, depending on the motor's design and the type of breaker used. as per section 430.52 and related tables. The specific type of motor protection also influences the selection. For example, dual element fuses are often used for motor short circuit and ground fault protection because they can withstand the high inrush currents associated with motor starting without opening unnecessarily. Inverse timed circuit breakers are another option, with their tripping characteristics designed to allow for motor starting currents while still providing protection against sustained overloads and short circuits. It's crucial to consult the manufacturer's specifications for the motor and the protective devices to ensure proper coordination and protection. Moreover, proper installation practices are paramount. The wiring connections must be tight and secure, and the enclosure housing the motor and its control equipment must be properly grounded. Regular maintenance, including visual inspections and testing of the overload protection, is also essential to ensure that the motor and its branch circuit are adequately protected. In summary, the branch circuit conductors for motors are protected by the motor overload protective device, which is selected in size based on the motor's full load current and other factors, as outlined in Article 430 of the National Electrical Code. This overload protection works in conjunction with the short circuit/ground fault protection to provide comprehensive protection for the motor and its associated wiring. The selection of the correct overload protection device is critical for preventing motor damage and ensuring the safety of the electrical system. Always refer to the National Electrical Code and the manufacturer's specifications for detailed requirements and guidance. Finally, consider the impact of ambient temperature on conductor ampacity and motor performance. High ambient temperatures can reduce the ampacity of conductors and increase the operating temperature of motors. Therefore, it may be necessary to direct the conductors or select a motor with a higher temperature rating if the motor is installed in a high-temperature environment. The National Electrical Code provides tables and guidelines for directing conductors based on ambient temperature. Additionally, it's important to ensure that the motor's ventilation is not obstructed and that the motor is properly cooled. In addition to thermal overload relays and circuit breakers, electronic overload relays are also commonly used for motor protection. These relays offer advanced features such as adjustable trip settings, remote monitoring, and communication capabilities. Electronic overload relays can provide more precise and reliable motor protection compared to traditional thermal overload relays. When selecting an electronic overload relay, it's important to consider the motor's characteristics, the application requirements, and the desired level of protection. Furthermore, it's essential to properly configure and calibrate the electronic overload relay to ensure that it provides adequate protection without nuisance tripping. Another important aspect of motor protection is ground fault protection. Ground faults can occur when a motor winding comes into contact with the motor frame or other grounded metal parts. Ground faults can cause significant damage to the motor and can also create a safety hazard. Ground fault protection devices such as ground fault circuit interrupters can detect ground faults and quickly de-energize the motor circuit, preventing damage and reducing the risk of electrical shock. The National Electrical Code requires ground fault protection for certain types of motor installations, such as those in healthcare facilities and those serving sensitive electronic equipment. The selection and installation of ground fault protection devices must be done in accordance with the National Electrical Code and the manufacturer's instructions. In addition to overload protection and ground fault protection, other types of motor protection may be required depending on the application. These may include phase loss protection, phase imbalance protection, and undervoltage protection. Phase loss protection protects the motor from damage due to the loss of one or more phases of the power supply. Phase imbalance protection protects the motor from damage due to unequal voltages on the three phases of the power supply. Undervoltage protection protects the motor from damage due to low voltage conditions. The selection and installation of these additional protection devices must be based on a thorough analysis of the motor's operating conditions and the potential hazards. Regular testing and maintenance of motor protection devices are essential to ensure their proper operation. Overload relays should be tested periodically to verify that they are tripping at the correct current level. Ground fault protection devices should be tested monthly to ensure that they are functioning properly. Additionally, All wiring connections should be inspected regularly to ensure that they are tight and secure. Proper motor protection is crucial for ensuring the reliable and safe operation of electrical systems. By following the guidelines of the National Electrical Code and the manufacturer's recommendations, it's possible to provide adequate protection for motors and their associated wiring. It is important to stay updated on the latest codes, standards, and technologies related to motor protection to ensure that the electrical systems are safe and efficient. Remember to always consult with a qualified electrician or electrical engineer for any questions or concerns regarding motor protection.